So, welcome back to our panel on time documents, Zeitzeugnisse, time testimonies. It's already late in the evening, but there are still a lot to discover. And our next guest will take us on another journey of discovery, and this time the trip goes to Greece. It's my pleasure to give a warm welcome to Paul Iversen. He has arrived from the US, and thankfully financed by a guest stay from the Einstein Center Kronoi, and invited on the initiative of Dr. Sebastian Prignitz, head of the Akademie Vorhaben Inscriptiones Graecae. And Sebastian Prignitz will give a short introduction in German, and then Paul Iversen will talk in English about the Antikythera mechanism and tell us what it is all about. And they have also brought something special with them, so get ready for some surprise.
Ja, vielen herzlichen Dank. Ich darf ein paar einführende Worte sagen. Mein Name ist Sebastian Prignitz, ich bin der Arbeitsstellenleiter der Inscriptiones Graecae. Das ist ein Vorhaben, das existiert seit 209 Jahren in Berlin, und zunächst war es auf 10 Jahre geplant. Es hat ein bisschen länger gedauert. Und unsere Aufgabe ist es also, alle griechischen Inschriften zu edieren des griechischen Mutterlandes. Und das sind also vor allem Steintafeln, Marmortafeln, in die also die Griechen mit Meißeln Inschriften gehauen haben, wo sich also Dinge finden wie Abrechnungen, Dekrete, Staatsverträge und natürlich die große Masse Grabinschriften. Gestorben ist man immer. Und in diesen Steininschriften, da finden sich also interessante Dokumente, absurde Dinge manchmal. Ich habe gerade eine Stele ediert, die von einem Elfenbeindiebstahl handelt, wo also ein Bauunternehmer Elfenbein hat mitgehen lassen und ähnliches mehr. Und im Lauf dieser Arbeit, da stoßen wir also nicht nur auf absurde Dokumente, sondern es gibt ganz unbekannte Orte, kleine Inseln, die plötzlich ins Zentrum der Aufmerksamkeit rücken. Und eine dieser Orte ist also die Insel Antikythera. Die liegt auf halber Strecke zwischen der Peloponnes und Kreta. Und vor dieser Insel ist also von Schwammtauchern ein Wrack gefunden worden. Das ist also vor über 100 Jahren, 1901, ist es also entdeckt worden von Schwammtauchern. Und da hat man also verschiedene Dinge gefunden auf diesem Wrack. Marmorstatuen, Bronzen, Glas, verschiedene Keramik, Amphoren und anderes Material. Und einen verbackenen, sehr korrodierten Mechanismus mit Zahnrädern und rätselhaften Inschriften. Da sehen Sie schon einiges. Und diesen Mechanismus nennt man also den Mechanismus von Antikythera, weil er vor dieser Insel gefunden wurde. Und wovon wollen wir heute Abend hören? Ich will Ihnen noch eins mit auf den Weg geben, was relativ wichtig ist. Jede griechische Polis, jede Stadt in Griechenland hatte andere Maße, andere Gewichte und andere Monate. Also sie mussten sich im antiken Griechenland immer fragen, wenn sie jetzt von Athen nach Korinth gereist sind, welchen Monat haben wir gerade? Ja, welche Festspiele stehen an? Welcher Tag ist heute? Also das ist sozusagen wie im mittelalterlichen Deutschland mit den Duodezfürstentümern, dass man also andere Maße, Gewichte und selbst Monate hatte. Und darauf nimmt also dieser Mechanismus auch mit seinen Inschriften Bezug. Der erklärt Ihnen sozusagen etwas, wo Sie sich gerade befinden. Das Schiff das Sinken dieses Schiffs, das wohl auf dem Weg nach Rom war, wird datiert um 60 vor Christus. Ja, nun ist es mir eine besondere Freude, unseren Referenten vorzustellen. Herrn Professor Paul Iversen. Sie haben ja schon einiges über ihn gehört. Er ist Chair des Departments for Classics an der Case Western Reserve University in Cleveland, Ohio. Und seine Ausbildung hat er genossen an der Ohio State University. Und zwar durch einen Mann, der uns auch miteinander verbindet, Stephen Tracy. Das ist also ein Epigraphiker wie wir, der in der Lage ist, Ihnen, wenn Sie nach Athen fahren, zu sagen, welcher Steinmetz die Inschrift geschrieben hat. Er kann also die Hände identifizieren, und das ist also unser gemeinsamer Lehrer, von dem ich, als ich in den USA, in Princeton war, auch eine Menge gelernt habe. Ja, und wir werden von ihm heute etwas über den Antikythera Mechanismus hören, von dem Sie hier eine Replik sehen, die am Schluss Ihnen auch vorgeführt wird. Die ist also von beiden Seiten zu öffnen, und da sehen Sie also, wie dieser Mechanismus ausgesehen hat. Der war aber etwas größer, also der war ungefähr so groß in der Realität. Ja, und was also Herrn Iversen auch hergebracht hat, ist, dass wir gemeinsam kooperieren. Das ist also für uns was ganz Wichtiges, dass wir mit ausländischen Partnern kooperieren. Und in unserem Fall ist es eine neue Edition der griechischen Inschriften von Korinth. Es wird also der Band Inscriptionis Graecae 4, zweite Auflage, 4. Band. Daran arbeiten wir zusammen. Und jetzt freue ich mich besonders, dass wir ihn hören werden und dass er uns in die Geheimnisse dieses abenteuerlichen Mechanismus von Antikythera einführen wird. Vielen Dank.
Function? Does it work? Can you hear me? Yeah. Okay. I want to thank the good folks at Inscriptionis Graecae and also at the Einstein Center Kronoi for the invitation to speak this evening about the Antikythera mechanism. And I see Professor Funke is here in the audience and Daniela Suma, people from Inscriptionis Graecae. It's very nice. And of course, I especially want to thank Sebastian Prignitz for the invitation. And also, I know it's a difficult hour for you, but for me it's perfect because 10 o'clock at night is only 4 in the afternoon from where I come. So, all right, let's start at the beginning of the story. Around 60 BCE, a large cargo ship loaded with precious goods sank off the coast of the sparsely populated islet of Antikythera. 2,000 years later, around Greek Easter of 1900, Greek sponge divers from Symi, and in particular Elias Lykopantis, pictured here, discovered the shipwreck and months later reported it to the Greek authorities in Athens. An expedition was organized using early diving suits like the one seen here, and between November of 1900 and September of 1901, the shipwreck was salvaged under extremely adverse conditions. One diver died and another one was permanently paralyzed. And it was the first nautical archaeological expedition of its kind. And the goods found were deposited in the National Museum in Athens, where they still reside to this day. The items discovered included fine marble statues, fine bronze statues, fine glass, pottery, amphorae, and a curious device now known to the world as the Antikythera Mechanism, so named after the island in whose waters it was found. So what was the Antikythera Mechanism? As we now know, after 120 years, the Antikythera Mechanism was a highly sophisticated, portable, geared astronomical cosmos that calculated and visualized the positions of the sun, moon, and also the 5 visible planets with respect to the zodiac, according to a pre-Copernican geocentric model of the cosmos, most commonly associated with the 2nd century AD astronomer Ptolemy. It also described a set of eclipse possibilities using the Saros and Exeligmos cycles. It had a dial that indicated 6 pan-Hellenic athletic games in chronological order in a 4-year period that was similar but not identical to an Olympiad. It also visualized and tracked a lunar solar calendar of some Greek state based on the Metonic cycle and probably also the Calippic cycle. All those terms I shall define in a moment. And finally, it had 2 extensive inscribed users manuals. Part of one I've shown here, known as the back cover inscription, that was sort of an Antikythera Mechanism for Dummies manual. And another I show here, known as the front cover inscription, that laid out the theory behind the planet's movements. Alas, it could not transport you in time as the latest Indiana Jones movie suggests. After the mechanism was salvaged, probably in early August of 1901, its bronze fragments were apparently thrown in a bronze sorting pile in the National Museum, where they lay unremarked while all the bronze statues got all the attention. But in May of 1902, it was noticed that there was writing on the fragments, and an expert epigrapher named Wilhelm was invited to give his opinion on the date of the writing and to read what he could. He dated the writing to the 2nd and 1st centuries BCE, and he detected the words Heliou actina, or ray of sun. This immediately led one numismatic scholar named Sphoronos, I'm getting a little bit ahead here, no, that's right, named Svaranos, who was planning a complete publication of the Antikythera finds under the pseudo-umbrella of the National Museum to declare it was an astrolabe, a device used by mariners to ascertain latitude and the position of the sun by using the rays of the sun. Svaranos found an ally in a historian of naval science and sub-lieutenant in the Greek Navy named Rediades. The view of both men, however, was opposed by a professor of nautical archaeology and history named Rados, who rightly noted the gears were too complex for an astrolabe. Initially, he suggested it may have been a nautical hodometer, a device for measuring the distance a ship has traveled. This set off a dueling set of articles in local Athenian newspapers between these two groups of scholars as to whether it was an astrolabe or something else. In any case, the initial examination of the ship's finds led a group of archaeologists in February of 1903 to declare the ship's contents dated to the 2nd or 1st century BCE. But Svaranos was undeterred, so he had Rediades publish it in 1903 as an astrolabe. He also ignored Wilhelm's date of the writing and the Greek archaeological community's dating of the cargo, and he put it much later, during the time of Constantine the Great, or 303 to 337 of our era, and he even presumed to argue the boat was coming from Constantinople and was loaded with statues whose origin was Argos. This is a good point to talk about the date of the shipwreck. In the 1950s and 1960s, a group of scholars called the Weinberg Group, and around 2010, various scholars tasked by the National Museum at Athens have endeavored to date the shipwreck more precisely by looking at the everyday contents recovered from it, because the everyday contents will tell you the date of the shipwreck rather than the fancy statues and things like that. Based upon the content shown in this slide, particularly the coins, we can say with high confidence the shipwreck dates to about 60 BCE. From this, we can also say the ship almost certainly originated along the coast of Asia Minor. The logical candidates are Pergamon, Ephesus, Kos, or Rhodes, which you can see all of them in this map here. So Pergamum, Kos, Rhodes, maybe, and Ephesus. The coins are from Pergamum and Ephesus, and the amphorae are from Kos and Rhodes. All right. Probably the ship was on its way to Rome to sell the goods, with a probable stop-off point in northwest Greece. In a moment, we'll see some evidence tying it to both Rhodes and also to Epirus. Back to 1903. From 1903 to 1905, a specialist in preserving bronze named Othon Rousopoulos began the delicate task of cleaning and separating the various fragments. This allowed a German scholar named Rahmen, who was an expert in Greek astronomy and epigraphy, to read more of the inscriptions, and in 1907, he published a searing review of Svaranos and Rediades' contention it was an astrolabe. He also was the first to speculate that the mechanism was a kind of planetarium. He identified some numbers on fragment 19 as referring to important periods in Greek astronomy, but a lack of technology to peer inside and advancements in his career resulted in him never having time to publish his notes, which can still be consulted at the Bayerische Staatsbibliothek München. In 1934, a quirky publication by Theophanides made no real contributions, although he was the first to realize that the number of teeth on the gears played an important role in interpreting the device, and he even made a working model that still exists. During World War II, the mechanism went into storage, but in the 1950s it was brought back out, cleaned and rephotographed, and a historian of technology and science named Derek de Sola Price was allowed to study it in person. This resulted in him being the first to assemble the major fragments in their correct positions. Later in the 1960s, he was able to make use of more modern X-ray technology to count the gear tooths. And with the help of the trained Greek epigrapher George Demiris, was also the first to publish in 1974 the significance of the references to the numbers 76, 19, and 223 on fragment 19, which Rahmen had recognized long before. These numbers are extremely important numbers in the study of ancient Greek astronomy and lunar solar calendars. For 76 is the number of years in the ecliptic cycle, 19 the number of years in the Metonic cycle, and 223 the number of months, lunar months, in a Saros cycle. At first, Price believed the device may have been a kind of planetarium, but in the end, based on the evidence before him, he argued that the Antikythera mechanism was only an ancient computer that calculated these astronomical periods, which again, I'll define in a moment. After Price, in 1985, a lecturer at the Royal Institute, at a lecture at the Royal Institute of Great Britain, a mathematician named Christopher Zeeman noted that Price's reconstruction of the gear train, quote, involves a substantial step-up mechanism. It is like trying to alter a clock by pushing an hour hand and expecting this to drive the minute hand 12 times as fast, unquote. This piqued the interest of Alan Bromley and Michael Wright, who teamed up and were able to take more X-rays of the mechanism, but Bromley would pass away before he could make use of them. The work was carried on by Wright, an expert in the history of technology, especially clock-like devices, and a tinkerer himself. Through his work, he was able to improve on Price's theories and models. Now we come more to the present. In 2005, an interdisciplinary group known as the Antikythera Mechanism Research Project, hereafter AMRP, applied newer technologies to the study of this remarkable device, which now consists of 82 fragments of various sizes displayed here. These newer technologies include Hewlett-Packard's Polynomial Texture Mapping, now more commonly known as Reflectance Transformation Imaging, or RTI, which consists in taking several digital pictures of the fragments with lighting at various angles, and then using a computer program to manipulate the angle at which the light hits the surface, thus helping especially to read the inscriptions inscribed on the surface. More important than PTMs is a technology called Micro-Focus X-Ray Computed Tomography, which allows one to create exact 3D models of the inner parts of the mechanism, so accurate that you can even read inscriptions inscribed on the inner surfaces that had not been seen in over 2,000 years. Using these two technologies in 2008, members of the AMRP published a paper in which they revealed that the upper dial on the back contained what they called a Metonic spiral and games dial. Here they showed that this dial had a spiral of 5 turns made up of 235 cells, within each of which was inscribed the name of a month from a particular calendar, which they correctly identified as belonging to the Corinthian family of calendars. They also suggested its first month, Phoinakaios, began shortly after the first new moon after the autumn equinox. Let me quickly explain the logic of lunar solar calendars. First of all, Greek months were lunar. That is, they closely tracked the phases of the moon. When the first crescent moon was ideally the first of the month, the full moon ideally around the 15th or the middle of the month, and the new moon, that is when you could see no moon, the last day of the month. In addition, almost all Greek months were named after an important religious festival that occurred in them. So, for instance, the month of Carneas at Sparta and other Doric city-states was the month in which the Carnea festival took place in honor of Apollo. These festivals were tied to specific seasons, and it was thought very important that the gods have their sacrifices on time. The trick of any good lunar solar calendar, then, was to find an integer number of days, an integer number of lunar months, and an integer number of tropical years arranged to keep specific lunar months tied as closely as possible to specific seasons. The problem is that lunar months vary from up to 6.5 hours from their mean every month. But over time, it was understood that they average about 29.53 days, which unfortunately is not an integer. But it is close to 29.5. So if you multiply that by 2, you get the integer of 59. So generally, lunar solar calendars alternate between months of 30 days and months of 29 days to make the integer 59. But if you have 12 such months and you only end up with a year of 354 days, about 11 1/4 days shy of a tropical year of 365 1/4 days. It also happens to be the case that 235 lunar months is nearly equivalent to 19 tropical years, which is 6,940 days, off by less than 2 hours. So this is the magic period where one can find an integer number of days nearly equivalent to an integer number of lunar months that is nearly equivalent to an integer number of tropical years. But 19 times 12 equals 228, not 235, short by 7 lunar months. So what lunar calendars do is insert or intercalate an extra 7 lunar months at regular intervals over 19 years. That is, if you have months alternating between 30 and 29 days, and you insert 7 extra lunar months in at regularly spaced out intervals throughout 19 years, you will have a calendar that both tracks the phases of the moon, so that the first of the month is at around first crescent, the middle of the month around full moon, and the last day of the month at conjunction, or new moon, when no moon is visible. And you will also keep these months tethered as closely as possible to specific seasons. This is the Metonic cycle, so named after Meton of Athens, who is said to have announced its discovery in Athens in 432 BCE, although we know the Babylonians were already using this by about 500 BCE. By the way, this is what the traditional Jewish calendars and Chinese calendars still do today. But if you follow the Metonic cycle strictly, this implies years of 365 and 519 days, a tad too much. So in 332 BCE, an astronomer at Athens named Callippus noted that after every 4 Metonic cycles of 76 years, 1 day should be removed to make the year 365 and a quarter days. This is known as the Calippic cycle, and since that inscription I mentioned earlier on the mechanism mentions the figure of 76, we can be pretty certain the mechanism also employed the Calippic cycle and had a Calippic dial, but this is now lost. Let's talk a little bit about the calendar that is found on the mechanism, specifically to what city did this calendar belong, and those are the names of the months of the calendar in their order. Naturally, this evidence also might impact arguments about where the mechanism was constructed or for whom. As members of the AMRP recognize, these months seem to have been present in the calendars of Corinth, Corinthian colonies in northwest Greece, and in the calendar of Epirus, also located in northwest Greece, as this slide shows. In the next slide, we'll see there is more evidence found on the mechanism itself that also ties it to Epirus, so this is the preferred choice for the calendar. The MRP also speculated that since the calendar could have originated in Corinth, and since Syracuse was a colony of Corinth, the calendar could also be that of Syracuse, the home of Archimedes, whom ancient sources say built an orrery similar to the mechanism, but about whose calendar little is directly known. However, I have examined the evidence of Syracuse's calendar closely, and the calendars of its colonies or nearby military outposts, such as Acrae, and it is clear that the calendar cannot be that of Syracuse. This is somewhat disappointing, as the connection of the mechanism with Syracuse, the home of Archimedes, was such a good story, and of course, Indiana Jones picked that up. Obviously irresistible, but it turns out to be wrong. And in a moment, I'll give you more positive evidence that ties the mechanism directly to another known astronomical center in the Greek world. In 2008, the AMRP also identified a games dial, which they called the Olympiad dial, but it does not track Olympiads, so I will call it the games dial. This lists 6 religious festivals at which athletic events took place, seemingly in chronological order, including the 4 most important sets of games in antiquity: the Isthmia on the isthmus near Corinth, the Olympia at Elis, the Nemea at Nemea Argos in the Peloponnesus, and the Pythia at Delphi. The other 2 games are the Naa at Dodona in Epirus, and one set of games the AMRP, as it was comprised in 2008, could not decipher. Of course, I was very interested in what games were missing, and using some of the 2005 data, I was able to decipher these last set of games. They are the Haliea of Rhodes, which a Pindaric scholiast tells us finished 6 days after the Nemea, thus adding more evidence that these games were listed in chronological order. These games are also important because Rhodes had long been thought of as the most likely place where the mechanism was built by Rahmen and early scholars like that. And this reading finally presented evidence that directly tied the mechanism there, even though, as you can see on this map, Rhodes is geographically far distant from the other games on the mechanism. And the games Haliea, the way they're spelled in the Doric manner, and the only word on the entire mechanism that is spelled in Doric Greek. The rest is all in the language of science, Attic Ionic. All right. The other odd set of games are the Na'a, the very minor Na'a of Dodona and Ypres, the same geographical area where the calendar was in use. I thus have theorized that the mechanism was built on roads for a client in Ypres. Now we turn to the lower dial in the back. In 2006, members of the AMRP in a seminal article established that the lower dial on the back face of the device consisted of 223 cells, each representing a lunar month, that described a series of eclipse possibilities using the Saros cycle. That period of 223 lunar months first recognized by the Babylonians in the Neo-Babylonian period of 626 to 539 BCE as being useful to ascertain recurring solar and lunar eclipse possibilities. The eclipse possibilities are referenced via a series of highly abbreviated inscriptions referred to in the literature as glyphs, inscribed within some of the 223 individual cells. Here, sigma, right there, stands for Selene, or lunar eclipse, and the eta down there stands for Helios, or solar eclipse, and then the monogram for Hora, it's an omega rho, and sometimes you get an alpha in there, stands for Hora, or hour, and the hour is stated with a Greek letter, in this case, both of them thetas, which refers to the 9th hour of the day. Other glyphs indicate if an hour at night is expected. Now, it just so happens that 223 lunar months after 223 lunar months, a similar eclipse happens, but it moves off an average of about 8 global hours. And since 8 hours is roughly 1/3 of a day, after 3 saroi of 223 lunar months each, the same eclipse returns to roughly the same global region and roughly the same hour of day. This more accurate period was discovered by the Babylonians, probably by the 4th or 3rd century BCE, and it was also known to the great Rhodian astronomer Hipparchus by around 140 BCE. The Greeks referred to this as the exeligmos. And in 2008, members of the AMRP announced that the mechanism also had a smaller dial here, the smaller dial here, known as the exeligmos dial, to keep track of this more accurate eclipse possibility period. Just to bring this idea closer to home, or at least to my home in Cleveland, Ohio. On March 7th, 1970, a total solar eclipse known as Saros 139, number 27, ran up the east coast of the United States with the greatest eclipse at 1738 Universal Time. 18 years and 11 days later, or exactly 223 lunar months, on March 18, 1988, Saros 139, number 28, moved about 8 global hours west and ran through the Pacific, including through the Philippines, with the greatest eclipse at about 2 o'clock Universal Time, or about 8.5 hours later. You can see it has more or less the exact same shape as it had in the earlier version. And then 18 years and 11 days later, or exactly 223 lunar months, on March 29, 2006, Saros 139, number 29, ran about another 8 global hours west through Africa and up through Turkey with the greatest eclipse at 10:12 Universal Time, or about exactly 8 hours after the previous one. And on April 8th, 2024, exactly 223 lunar months later, Saros cycle 139, number 30, will go directly over my hometown, Cleveland, and its greatest eclipse will be at 1818 UTC, pretty close geographically and almost exactly the same hour as 3 Saroi periods before. The amazing thing is that the makers of the mechanism and the Babylonians knew this, and they were able to keep track of it. In the 2006 publication, however, the AMRP did not identify a precise set of historical eclipses, but after the 2006 publication, several groups of scholars working independently identified that cell 1 of the Saros eclipse dial commenced with the month that began around April 29, 205 BCE. Some have taken this as evidence that the mechanism dates to about 205 BCE, but I think rather it dates to around the time of the shipwreck or 60 BCE, and may have actually been new cargo on board that was being delivered. And you know, if you think in astronomical terms, 2 Callipic cycles of 76 years each, that's about 150 years. And if you go from the shipwreck back, only 2 Callipic cycles, you're at 205. Using this information, in 2017, I argued that while the Saros dial startup date was April 29, 205 BCE, the first day of the first month of the Metonic spiral, Phoenikaios, began on about August 24, 205 BCE, and this helped explain why the Exeligmos dial is rotated about 32 degrees. And you can ask me about that, what that means later. In 2019, Alexander Jones and I were able to make some improvements on reading the Saros glyphs and the index letters that refer to them, which I don't have time to describe in detail. I only say that we have improved and I think settled the disposition of the index letters on what's called the backplate inscription and the glyphs on the Saros dial. Finally, I would like to cover issues surrounding the front dials. In their 2006 publication, the AMRP, and in particular Tony Freeth, pictured here, published this version of the front dials. Basically, the front dials are dominated by 2 large concentric rings, these 2 large rings. The zodiac dial is the inner one, and the Egyptian calendar scale is the outer one. And within this, you have at least 3 pointers. The first of which was the moon ball apparatus, which is here in the center. This is the moon ball apparatus, and that still exists. And then the second, he put in a second pointer for the true sun with a golden sphere on it, because an inscription mentions a pointer for the sun with a golden sphere on it, and a third pointer for the mean sun. So his model in 2006 had only 3 pointers on it. And this little replica here, it puts 2 pointers in kind of based on, I think, their first version of this in 2006. All right. All right. Now, I wish I had time to go into how cool the moon ball is, which Michael Wright had identified in 2006, and which was probably painted half black and half white and mimicked the phases of the moon. And not only that, but through a pin and slot device, the oldest known pin and slot device, the mechanism was able to mimic the anomalous motion of the moon in accordance with Kepler's second law. But I don't have time to cover all of that. Anyway, the AMRP left open the possibility that there may have been more displays for the planets, as Michael Wright had advocated and Rahmen had suggested long ago, but there was no surviving epicyclic gearing for them. If they are there, they would need to have been located in the part of the mechanism that is lost between what is called fragment A and fragment C. So right in this space here between this plate and this plate. Many scholars after 2008 proposed such gear trains. In the meantime, Alexander Jones was working diligently for the AMRP, deciphering more of the inscriptions, and by 2011 he had ascertained that what are known as the front and back cover inscriptions mention all 5 visible planets as well as the term cosmos. This meant that the 2006 publication only showing the moon and the mean sun and true sun was incomplete. In a private email to Freeth, he suggested that the planets may have been embedded in concentric rings so that rather than the planets rotating on pointers, as is the case of the sun and the moon, the rings rotated and thus the planets along with the rings. We have many medieval manuscripts with such pictures of rings for the cosmos. Freeth felt at the time that such a design was not feasible, so in 2012 he and Jones published a new model of the mechanism showing the 5 planets rotating on pointers in a kind of portable cosmos, as in this diagram here. You can see all 5 of them now are on pointers and they're all there. which would require a robust set of lost epicyclic gearing between fragments A and C. After this, members of the Antikythera Mechanism Research Project published or republished all the major inscriptions of the mechanism in 2016, and these inscriptions established that without a doubt that what are known as the front cover inscription and the back cover inscription both referred to not only the sun and the moon, but also the 5 visible planets in antiquity, namely Mercury, Venus, Mars, Jupiter, and Saturn. And there would be no reason for the text to mention these in their cycles unless they're being shown on the mechanism. These texts also established that the theory behind the movement of the planets included epicycles, a theory best known from the works of the great astronomer Ptolemy, who worked around AD 150. But Ptolemy tells us this theory was demonstrated by a 3rd century BCE astronomer, Apollonius of Perge, and it is usually assumed he was the one who discovered it. Based on the text published in 2016 and in 2021, Freya thin reverse course and essentially took Jones's idea from 2011 and worked out a very impressive mechanical model that uses rings rather than pointers. Although I have a few quibbles listed here with Freya's model, let me say it's a real attractive solution because it seems more consistent with the inscriptions. So I'm sorry, this model here is inadequate because it only has 2 pointers on it, but that's okay, it's an early version. Now, I should mention that I'm working on a complete reedition of all the inscriptions on the mechanism, which still hold some surprises, and I'll be giving a second talk on some of these inscriptions on January 25th from 1500 to 1600 at the Einstein Center, Kronoi in Dahlem. As for literary references to such devices, there may be an allusion to a planetarium as early as Aristotle, but the earliest unequivocal references are found in Cicero and date to about 50 BCE, right around the time of the shipwreck. In this first quote from Cicero's De Republica, written 54 to 51 BCE, there is a famous reference to orreries built by Archimedes of Syracuse that were taken as the spoils of war by Marcellus when he defeated them early in the year 211 BCE. This is our earliest reference to such devices. The reference, though, is problematic since it takes place as part of a fictional dialogue set in 129 BCE, but nonetheless provides evidence of such devices, possibly as far back as Archimedes. The second quote also comes from Cicero in his De Natura Deorum of 45 BCE. This passage has an explicit mention of an orrery built by Posidonius of Rhodes, where Cicero studied earlier in his career. And here I should point out the connection with Rhodes once more, and that around the time of the shipwreck. But I want to make it clear that I don't want to associate the mechanism with Posidonius himself, as Rahmen did, since it appears that there may have been a kind of industry around building these devices. Finally, to conclude, one naturally wants to understand the purpose of the mechanism. In this mosaic of Roman times found at Pompeii, we see a group of philosophers sitting around a globe down here in a wooden box. And originally the mechanism was also in a wooden box, but the wood all disintegrated. But you can see, I'm sorry, you can see here that we've got the wooden box here, just like it would, right? All these literary sources, there are like at least 22 ancient literary sources. There was quite a few that mention devices like this. All of those mentions in literary sources, the function is philosophical and educational. So these mechanisms, they were built as a sort of tour de force meditation upon the functioning of the cosmos. Another question is why they ceased to be made. One reason is that they are very labor intensive to build, requiring specialized labor of at least 2 full months, according to Michael Wright, who builds these by hand, and he doesn't use modern tools, he only uses ancient tools. They also had a relatively short working life and would have needed frequent repairs, or they very quickly would have become a pile of junk, like, you know, those toys you had as a child, and maybe they have a lot of backlash, and one gear goes wrong, and then it becomes pile of junk. That's what this would have happened to, unless somebody knew what they were doing to fix it. They also had very limited application to elites who pondered the universe. And given this context, it's not surprising that with the advent of Christianity, such devices no longer had a market or an audience or were smiled upon. So they ceased to be made. And that is my lecture for tonight. Thank you.
Thank you very much for this very fascinating talk. Well, I hope I understood in about a third of it or something like that, but maybe you can just try to explain it here with a model, even if there are only 2 pointers.
Yeah. So, okay, get out of that. So the front of the device would have the moon. This is the moon ball apparatus and the moon pointer, and the moon ball is there, and it would have circled and shown the phases of the moon as it went around the zodiac. So it's not like a planetarium today where you have the planets floating in three-dimensional space. It's just showing their motion through the zodiac, where they are in respect to the sky. All right, and then you have the sun pointer there, and the inscription on the back, the user's manual inscription, tells us that on the gnomon, on the pointer, there's a golden sphere. So we know that the sun had a golden sphere. And I'm working up a new text, and I believe the structure of the inscription that describes this, it introduces the planet, and then it tells you the color of the planet too. So I'm going to restore, like, Peroes, Mars is the red one on the front, and that sort of thing. All right. So it also had the other 5 visible planets. So it had the sun, the moon, and the 5 visible planets, and showing how they went through the zodiac. Now the thing about the planets, the word planet comes from Greek, and it means wanderer, because from the point of view of somebody on Earth, it seemed all the stars, they all go from east to west. And the sun goes from east to west, and the moon goes from east to west. But the wanderers, it would seem like they would go from east to west, and then they would stop. And then they would go backwards. And then they would stop. And then they would go forward. And then they would stop again and go. So that's because they thought that the Earth was at the center, but of course the sun is at the center. So from the viewer on Earth, it looks like they're wandering back and forth. And so this front inscription here describes the theory behind the planet's movements. And it says, it says that like a planet, like for Venus, it says that it will return to its original position in 462 years, but along the way it has a bunch of like 389 epicycles. And each epicycle takes a solar year, basically. And so they explained this retrograde motion by saying that the planets had little epicycles while they went around the Earth. Okay? And so this inscription explains all of that front display and the theory behind it. The back has 2 large dials. The top one has 235 cells, each with a month scribed in tiny letters. Lettering in this area and in other parts, it's like 1.5 millimeters tall. The biggest letters are 3 millimeters on this thing. The box is about the size of a shoe box. It's about twice the size of this, I would say, twice the size of this. So they already were trying to manufacture clock-like devices as miniature as possible. So the idea of miniaturization was already, the Swiss were not the first ones to do that. So it has these 235 cells, each representing a lunar month, the 235 cells of the Metonic cycle. And it also tells you so you have months with 30 days and months with 29 days, and it indicates which months you need to remove a day from. Now, because it's technically you remove every 64th day. And then that way, in 7,940 days, you'll have them spread out exactly. It's almost every other month, but it's really every 64th day. And so it tells you which months you need to remove a day from. And then it has the games dial in here, which I described, the 6 Panhellenic games, and it tells you what year you can expect those games to be in and the general order. And then over here to the left is the mechanism. The pieces are broken, so it's only the right half that's visible here. And so the left half is missing, and so it's theorized there's the calyptic dial, the one, so you remove a day every 76 years so that your tropical years average 365¼ days rather than 365 5/19 day. And then down here is the Saros eclipse possibility dial of 223 lunar months. Some of these cells have a glyph in it to indicate that you expect a lunar eclipse or a solar eclipse, or some both. And they also tell you the hour of the day expected. And then the little dial in there is the Exeligmos dial. And so for the first Saros cycle, it tells you the time of day. And then when that little dial is in the second sector, it tells you need to add 8 hours to the glyph time. So if that dial is in the second sector, all those glyph times are wrong on that dial. You need to add 8 hours. If it's in the next sector, then you add 16 hours. And then once it gets back to the beginning sector, it's the same hour of the day that you expect the eclipse. So, and then this on the back here, it describes all the dials, both the back ones and the front ones, and tells you, how to interpret them and what they do. And so I'm working up my talk in 5 days. I'll cover this inscription here, called the back cover inscription. Got new readings there. And I'll cover the front cover inscription. And then on the front, there's also this thing called a parapegma text. A parapegma is a kind of... so before there were precise instruments to measure solstices and equinoxes, farmers needed a more reliable way to know what time of the year it was. And so they had developed a repertoire of the risings and settings of various stars or star clusters. So the most famous, the brightest star in the sky is Sirius. So Sirius has its morning rising at in antiquity in Greece's latitude. It was like at the end of July, our month. In Boston last summer, it was on August 13th. Which is a different latitude, and the stars progress now from antiquity. They're not in the exact same position. So this is an old way of keeping track of the tropical year. They didn't yet know that by the time the mechanism, I think, was made, Hipparchus knew that the sidereal year and the tropical year varied a little bit from each other. But it was still, that was the tradition of keeping track of the tropical year, another way of doing it. So I'm also going to talk about the parapegma text. I have some new readings for that. So that's how it worked. A lot packed in that little guy.
So thank you very much. I think that everybody here in this room is convinced that in your little shoebox there is an ancient world wonder hidden. But unfortunately, there's no time left for a discussion. But I'm sure that you are ready to accept further questions and with a beer in your hand or something like that.
Okay, yeah. So is this the last talk? This is
yes. Okay. No, it's kind of the last talk. I've got 2 things to do, and the first thing is, ich soll Sie alle hinweisen, dass die Lesungen weitergehen. Unterwegs in Zeit und Raum. Zeitreisen der Literaturgeschichte mit den Schauspielerinnen Corinna Kirchhoff und Nina West und Akademiemitgliedern beginnen um 23 Uhr. im Leibniz-Saal, wie heißt das? Leibniz-Saal, genau. Das soll ich Ihnen sagen. And the second thing I have to do is to say thank you again.